So, hello everyone. My name is Utkarsh, and I'm hosting this meetup here because I thought that there is a need of this because we all are in the same domain and we can learn by sharing our knowledge together. And all of us have like something to teach to each other and something from learn from each other. So that's the whole motive of having this meetup. So I am a senior software engineer at Sony PlayStation, and I'm active contributor to Grafana project, if you guys are aware about Grafana. And I'm also a project initiator for a command line tool for Grafana, which is busy. And that's my GitHub link and email. So first of all, I would like to thank Scot and Chad for hosting this meetup and giving us some good treats out there. and organizing everything. So a big thank you to both of them. And so the whole goal and mission, as I said, is to learn and share the same technology which we are using or different thing which we can teach each other. That's the goal. And the topic for today is efficient monitoring with Grafana. So I would like to ask you, how many people are using Grafana right now? Okay, so most of them, half of them actually. So, and then are you guys interested in like knowing about the data source more or data sources, or are you guys interested in like how to use Grafana efficiently, or like what are your goals of using Grafana or building your monitoring system? Like if any of you can just okay, efficiency and alerting. Yeah, because I want to keep it more interactive, and if you guys have any questions or if you want to say anything, we can just stop me and just say it out loud. So what I think that we know that monitoring is important, right? But we want to, and for our companies and organizations, we want to keep the outage time as low as possible, because when there is an outage, then we lost money. There's a revenue loss. So let's look at some of the numbers which I just gathered before the presentation. Like if you look at a Facebook outage, they lose about $1.75 million per hour. So if it's down, and then if there's an outage in Apple, then they usually lose about, in the App Store, then they usually lose about $2 million or something per hour. Then we go a bit bigger, which is Google ads or something is down in there. They leave. I got these numbers from some links, some studies. So you have the links for them later on. It's about $6 million, which is more. And then if you go to the biggest online retailer, which is Amazon, so and that's really huge for them if they lose, if they're not working for an hour or so. So I think main focus of monitoring should be to reduce the triage time or to reduce the outage time of our services. And if we don't have our monitoring set up in that way, then we are not doing the right thing, in my opinion. So our whole focus should be to use these tools which are available out there, like Graphite, Grafana, whatever open source tools are available, or even not open source which are proprietary. The whole focus should be on reducing the triage time. So for example, we have all of us might be working in big organizations, and we have complex architecture like this, whatever. Like one service depending on another, then their databases, then they are multi-region, and then it's all very complex. And monitoring each and every component of it is not easy. And then each component is different. There are so many languages out there. There's Golang, there's Java, there's so much. So each one of them is different, and how to monitor each one of them efficiently is the goal of monitoring, I think. So first step is obviously to collect the metrics from each and every component we have and visualize them. So for that, there are a lot of tools available out there. But the basic architecture is still the same, which is like you have different metric sources coming from different applications. It can even come from, like if you're hosting it on AWS, then you get AWS CloudWatch metrics. If you are running a Kubernetes cluster or something, then you have metrics coming out of that. If you have a Hadoop cluster, a Spark cluster, anything like that, then you have metrics coming out of any component or any service. So all these metrics will be going to a time series storage like database, and then there has to be a visualization layer. Some examples of these components, this is a unified stack all of us have, or all of us, are thinking to have. So some examples I have are these, like you can have collect the agents on servers, you can have JMX trans agents on servers to collect JMX metrics. Then you can have CloudWatch standings, Spark, Kubernetes, and then you can have examples of time series databases which are out there in open source right now, are Graphite, OpenTSDB, InfluxDB, Prometheus, yeah, all these things. And then you have Grafana as a visualization layer. So at the end, when you get all the metrics from all the different components, and then you have multiple data sources behind the scenes, you are gathering metrics from CloudWatch and everything, you end up with hundreds of dashboards. And then when an outage happens, the main problem is that where to look for. You have got hundreds of dashboards. Now at least you have some visibility, but you don't know where to start with. That, okay, for example, if some part of the site is not working, some part of the platform is not working, then you will at least go to that dashboard and try to look for. But then if that thing has a dependency on 10 different things, then where to go next, right? That's a main issue. So Grafana has some good features which can help us in making our outage time really like low and help us triage the problem as soon as possible. And that is why this meeting is about. How to use Grafana features to reduce the outage time. So I just spoke about that. Okay, so let's just say I just created a hypothetical website like buyshoes.com, and you have 3 services running supporting the website, which is catalog, auth, and payment. And then you have got load balancers, and then you've got servers which are talking to each other whenever needed, and then you've got database layer. And then each team for each of these components have, like in an organization, 1 manager and 3 engineers, for example, right? And then what we want is to make efficient dashboards so that each component or the service is monitored well, and also we notify and alert the right members with the right information. Because we don't want to like ping a manager and say, oh, your MySQL connections are going high. He cannot do anything. He will go back to the engineer and tell the thing about it to him. So we want to have like efficient mechanism using Grafana, because it provides those features which we can use and make our you can say our process more efficient. So let's say this is our monitoring stack for buyshoes.com. We have catalog stats coming directly from application, and some stats from auth and payment. And then we have some system stats, which is CollectD and AWS. We host it on AWS, going to OpenTSDB. And then we have Grafana in front. So this is our monitoring stack for buyshoes.com. So how should we think about designing our dashboards, right? So the architecture which I think about when building dashboards is like, okay, you should have one overall dashboard which should show the overall status of your platform, right? And then you should go from there. Like then you have a hierarchy in the organization. Like you have CEO, and then you have vice presidents, and then you have directors. So in that sense, we should be thinking dashboards in the same sense, because each component owner is responsible for their own services and components. And then, so in my opinion, that we should have a top level dashboard, then we have service level dashboards, which should alert to only managers and service owners so that they know what's going on in their service. And then component owners, like if there is a problem in servers, if there is a problem in database, then there should be an alert obviously going to managers, but it should go to the whole team as a whole, so that anybody from the team can look into the problem and solve it as soon as possible. So we should think in this kind of a design pattern, in my opinion. So that's what I thought about building dashboards for buyshoes.com. And we have good features from Grafana, like we can support multiple data sources, different panel types. Like you can have graphs, you can have single stats. Your users of Grafana, you guys know that. And those guys who don't know it, like you can have different kind of visualization patterns in there. So, and then now recently, they also introduced help text, so that if somebody is going to a Grafana dashboard and doesn't know what this graph represents, then you can have a tooltip right there, which can show you that, okay, what does it represent if somebody doesn't know about it. Because nobody wants to be on call, and if the people who are on call, if they don't understand your graph and dashboards, then it's really hard for them to triage the problem. So that's a very good feature right there, help text. Then I think one of the most important features is drill down links. Like you can move from one dashboard to another, or even from one dashboard to any other URL very easily in a single click. And that could actually really help you to make efficient dashboards. And then we have templating, and you don't have to reusing the same dashboard for different components. Like for example, you have different Cassandra clusters. So you want to make a single dashboard for any Cassandra cluster, and then you should just reuse the same graphs and the same stats for any other cluster. So templating is for that, and then finally you have got alerting, which can notify you what the problem is. So we'll use all these features to end the design architecture I just explained in the previous slide. Like we should have this kind of dashboards to build efficient dashboards for buyshoes.com. So okay, right there. So what I think after considering the Grafana features and the design pattern, that we should have 5 dashboards, and then one should be like overall status, which is like what's our platform doing right now. And then one should be at the load balancer or the service level, and then you have like the component level, which is server level dashboard, and then you should have one dashboard for each kind of service, which is MySQL and Cassandra. So if we have all these 5 dashboards up there in Grafana, then we do not need anything extra to monitor our platform, which is quite simple in this case, but obviously there are complex systems out there. So let's see. Let me bring up my local Grafana and show. Is it small? Okay. So for example, yeah. So this is the overall status dashboard I've built, and you can have different types of graphs. Like this is a line graph, and this is single stat. You have a spark line down there. So this shows the overall status of buyshoes.com, how many active users are there, how many clicks are happening per country, errors are happening per feature, things like that. How much? So that's the client status. You can see you have client status there. There's a server status. How much is your latency on each service or payment and catalog? How many requests you're getting per minute? Which is actually, these numbers are coming from AWS, if you're interested. And then these numbers are from PlayStation, but we're just considering for this example. And then how many errors you have on your load balancers. So this is an overall status of your service. And then once, oops, I just closed. Okay. And then if you just see here that it can take you directly to like Splunk, and you can search it. Log in. So if I'm already logged in, so if I click now again, so it will just directly take me to the search, and it will print the events directly. I don't even have to type the search query because I've already fed the information inside my panel here in general, and then here's the URL where I want to go from there. So that will actually reduce a lot of time in writing that query. And if somebody is not a Splunk expert, then how would you expect him to write that query, right? So you can. Right now in this example, it's a static URL. But at least you can give some start to the person who is trying to triage. So if you can give a static URL, it will write that query in the Splunk and show you the results, and then he can just go in and modify things right there. So it's really helpful, these drill down links.
The question is, you can't template that one?
You can, but the template variable names have to be the same. But in Grafana, I think this is from and to, like the time range variables. But in Splunk, it's something else. I don't even remember what exactly it is. But so if it is same, then it will work. But there are issues open in Grafana community which is for these kind of features. So we can have template variables correspond to the search components on the Splunk side, or even if you have Elasticsearch and Kibana and stuff, so you can even go there directly from here and directly have the search already open for you. You don't even have to type those kind of things. So that is one of the things which I think is really cool. You can move there, And then, do I have, okay. So if I see that there's an increase in latency or something, I can just go to another dashboard, which will take me to the service level of dashboard. How is my servers doing? How are my servers doing? This is just the system level stats, which is memory and CPU, load average, network. So I can actually move from one dashboard to another and create a flow myself. And if I see that there's an error, then I can just go to in the right direction where I should go. So we can set up alerts on this one, for example. Let's create an alert. Let's say we want to get alerted if it goes above 50%. And I think I need to have a alerting. There's no notification, but you can add a notification of your, whatever you want to have, say Slack. These are the options available for alerting, that you can have alerts on Slack, PagerDuty, VictorOps, and email as well, the old way. But anyway, Slack is there. You can either send on all alerts, like if any alert happens on your whole Grafana, then you can just checkbox this if you want. Otherwise, you can just mail it to yourself or your team. You can set all the configuration right here, and then what you're gonna get at the end is something like this in Slack. So you'll be able to see what actually the issue is, and then you can click it back and go back to the dashboard, which is right here, for example. It will take you to the panel directly. So you can go to the right panel or the dashboard, which will reduce the time which is for the outage. That's the whole goal of finding the problem. So that's there, and then you can also from here you cannot figure out whether this information is coming from AWS or OpenTSDB or Graphite, but you can have multiple data sources as well. I have Graphite and OpenTSDB, and let's see what else. So if I go to the service level dashboard, there's if you change like your app, it will just reflect the things right there. This is a Cassandra app, so it doesn't have any Apache connections. But anyway, but you can select different things, and you can still use the same dashboards for a particular app and see the same stats. You don't have to recreate the same dashboard for each and every other app. So these things are really important in making the dashboard efficient, and we can really reduce the triage time by having all these features. And there is one more thing I was the help text. So there's a help text which you can also say right here, like hello, this is help. And then you can when somebody comes to your dashboard, then if he just hovers here, you will come to know like what exactly this graph represent, and that will give information to the person who is triaging the problem right now. Because if you just, if this is vague, then nobody will understand what these graphs and numbers represent. So that's one of the things. So coming back to my presentation, so these are the things which we need to make efficient dashboards, like drill down links, directly going to searches, because the next level of triaging from the monitoring is logging. So you always, if you see that, okay, Cassandra is throwing errors or MySQL is throwing errors, then you go to Cassandra logs and MySQL logs. So you can just go there in a single click. You don't even have to type your searches. So those kind of things are really important. So these are some links which I want to share with you guys. Some of you might already know that there is Grafana documentation available. Then that's the GitHub link for Grafana. And this is a Slack channel where Grafana guys usually respond to the problems, or anybody in the community will respond to your setup if you have any problems. So you can just contact them. If I'm available up there, you can even ask me if there's any issue in your Grafana setup. And then I've initiated a project called VZ, which is a command line tool, which can do a lot of things when you want to interact with Grafana. Like for example, right now it's really hard to move a panel from one dashboard to another. You have to go into the JSON, you have to copy the JSON of the panel and then copy it into the another dashboard. But with Vizy, you can just say Vizy, copy, move, whatever, and then panel from dashboard A from first row to second. It's just a single line, and then it will just move your panel right away. And then you can also check in your dashboards into GitHub. It's a very useful tool, in my opinion. A lot of people are using it now. Even he's using it here. So I think that's really good. It's getting some use case. I'm open if you guys want to contribute back to it. We can make it better. And then again, yeah, my information. You can always contact me if you have any issues with Grafana related. Yeah, that's about it from my side. Very simple, nothing fancy. So I'm open to questions. Yeah.
So the alerting which is coming in on the graph now. What I remember that they have not started supporting it, the templates.
Yes.
How does the alert will work? Like when we have a system dashboard and posted my template variable in the drop down. Now, if I would define simple alert like for CPU, simplest one. So does it end up like defining errors for each host?
No, it should not. The whole goal is to have only one alert, which should just alert us like, okay, this host is bad, or this host is above 60%, 70%, and you just have to set up it like once. That should be it, in my opinion.
Right.
It depends on the project owners, actually, how will they implement it. But definitely we can, as a community, we can always go on the issue and say, we want it this way.
But at this point, they are not supporting that.
No, at this point, they are not. Yes.
Well, one of the things they have to understand is that if you start templating some of your dashboards, however you save it in whatever templates that you have, whatever parameters you have, the alerting will actually use those baseline templates. So if you want to save, like he showed a few different dashboards where, like, you have you have an application and he saved that application. That baseline variable is saved inside that template, so it will alert on that variable itself. So if you wanted to create alerting systems for multiple different applications, but it's all using the same template, you should create different dashboards that have that template defined, and then you can have alerts set up for each different template.
Yeah. And then any other questions before I tell about this? Okay. So let's get. So this is a project which I created, Vizy, which is a command line tool to make the Grafana interaction easy. And then there are a lot of commands which you can use. For example, if you look at a dashboard JSON, for example, let's see this one. It's really huge and messy, and you don't even know where your panel is, which you want to copy from one dashboard to another, and you have to search for it and then copy it to the other JSON and just import it back. What you can do with Vizy is more like you can go to the command line and I think it's So I can just do a summarize on any dashboard, which is, for example, app summary. That's a dashboard, I guess.
Did you figure it?
And I don't think so. I think so. Yeah. So it will just summarize the whole dashboard for you on in a single command. It will show you that the title is this, the row count is, there are 3 rows. What does the row contain? Like 3 panels. What are the panel names or titles? And you can just see, and then template variables. What's the time frame of the dashboard? So it gives you a very like summarized view of the whole dashboard on your command line. And then, for example, if you want to move this panel from there to here, or from this dashboard to any other dashboard, you can even do that. Let's see what if I do an ls, then I have directories for dashboards, I have directories for data sources, I have panels stored separately, so I can even do a panels on so this is a panel which I have stored separately, and I can just reuse this panel into any other dashboard. So this is just a command line tool which has a lot of commands right now. A lot of commands, like you can move rows from one dashboard to another, you can copy, you can even like extract it out and store it in Git so that you can reuse it later. And if somebody override your dashboard, you can always override with whatever you have in Git. So these are some of the tools which I wanted to share with all of you today, and that's about it. And I would like to invite Scott now for his presentation and his knowledge. Yep.
Appreciate the patience, guys, but I needed to have my notes so I can actually make this presentation, because I wanted to at least present you guys how we have our Grafana implementation here at Chegg. And first, I want to welcome you all. My name is Scott Melville. I'm a DevOps engineer here at Chegg, but most people know me by my nickname Nudge, or Graphy, or that guy who knows how to make web crawlers, or the guy they yell at when the website is down, or that monitoring guy, the third. So anyways, moving forward, I wanted to go ahead and just give you kind of like, the benefits of Grafana. So what are some of the benefits of Grafana? Well, as Utkarsh has stated, it's a great front-end tool that allows multiple teams and organizations to use one centralized monitoring station. As the metrics grow, so do the metrics and different sources. But one main concern is that everyone's using different dashboards or different websites to keep everything maintained. To kind of elaborate a little bit further, we have we have a Cassandra Ops Center that could be generating metrics, and an engineer knows how to get to that dashboard really easily. But then those metrics are being also being fed into Graphite as well, and another engineer knows how to use that source as a data source. And you have two engineers working on the same problem that are using two different data sources. And one of them is lagged, and one of them is not lagged, and one is not giving the right information. And then you have engineers not looking at the same data source together, and all of a sudden you could say, oh, I don't think there's any problems here because I see no issues, and they know about that legacy problem. And then the other engineer is unaware or oblivious to the problem. So the entire idea is that you want to have one centralized source for monitoring. So what Grafana can help alleviate the problem is that if you want to solve the monitoring problem, you have an access point for all your data sources, and then you give people access just to Grafana, and then they're able to get to any data sources they want as well. All right, and now for Chegg's implementation is actually running with Docker and containers. So why are we using the Amazon ECS model? Well, I love showing this slide because it really structures the use of Docker and containerized services. And this is the pets versus cattle model. So pets are basically given, they're uniquely named. You have a pet, and as soon as they get sick, you basically nurse them back to health. So you have that unique server that you guys want to use, and it's like, okay, it's having problems. So in order to solve it, you have to log into the system and take care of the logs, do some log rotates, or you have to do some services to make it better. And then as soon as it's better, everyone's happy again. Well, the cattle approach is a little bit different, where you have multiple servers all handling the same thing. They're almost identical, and what you want to do is if one of them gets ill or some cow decides to get mad cow disease, you can just shoot in the head and you get a brand new cow. So instead of having one isolated problem, you can actually just go ahead and get rid of one of your services, and then it automatically spins up a new service immediately, so you don't have to worry about those meaningless problems or any issues like that as well. So one good thing about this is that for our Grafana service right now, our DevOps team actually doesn't get any alerts or actually help take care of this system at all, because it has no logs to maintain, it has no CPU to maintain as well, and when these services do go down, a new one gets spun up fairly quickly. So it's something that I actually wanted to do. It's if we want to be able to not worry about problems or issues, we don't have to worry about those meaningless problems or issues that we don't want to answer to when things start alerting. Now, Docker and containers are just magic, right? Well, no, they just basically, what we want to do is we want Docker and containers that are here to keep things structured and the services readily available. The goal of using Docker to help out here we just want the service to work. But to have this pipeline ever fails, we can have it self-heal, or if if deployment fails, we can easily roll back. And that's kind of like, the whole idea of where most services are going now. We want to go inside the Docker and containerized world because as soon as something's busted, if we can get a new one immediately, then we have no downtime immediately. So taking that same philosophy that all of our other services that we want to, I implemented that into our Grafana implementation. So there's a lot of work to make this approach work, like, logging, monitoring individual tasks, build pipelines that people here at our company have built out and structurized. So that to actually get this to work, there's a lot of baseline work that our company did to enable me to actually do this. So big props to our development team and also release team that actually enabled us to have that build pipeline to create this product. So why do we want to push Grafana into Docker and ECS? Well, the main reason is because Grafana 4 came out, and it came out with an alerting system. When we had this come out, I really saw this as an opportunity that we can create a new monitoring system based off Grafana, and also give the ability for me to actually learn about Docker, containerized instances, and things like that. So it's cool to learn new tools, and I wanted to basically just learn how to be the fun little whale, and it's a whale of a good time. But I firmly believe that if you're always trying to push yourself to learn and grow as an engineer, if something interests you, you should pursue it and make it your own. So that's basically what I did with the Grafana services. So to get into a little bit more about our features that we currently have, the Docker implementation, all the images are pushed to Amazon ECS. The Jenkins build pipeline, we have a dev, test, stage, and production instances all using that are all being used right now to build out anytime we have a new update or anything like that as well. So what we're actually able to do is we actually have the latest nightly builds are built in our development environment. We have a test one where we can have a enumerated build where we know it's stable and it works properly, so we can still use that for the test environment. Or if we want to push it to production, we can see if it actually works and actually push it into production later. And then we also have automatic deployment, so if the service dies, we can spin something up. Everything is managed through LDAP, so users are automatically given the access as they needed. We have a mail service where for alerting and images are actually generated and hosted on our S3 buckets. And we have an SMTP service using Postfix to actually send out the alerts. So the Grafana host itself can actually send out all the different emails to any teams or any people available. So you can use email, or you can use VictorOps, or you can use any other services that you can. And one of the main things that we wanted to push out with using S3 is that we can actually generate URLs and pictures of individual graphs. Now, where that's going to come out useful is later down the road when we have VictorOps and other alerting systems available, that instead of having a link to the actual dashboard, that could be okay, that link to the dashboard is under a VPN, but you don't want to take your phone and connect to the VPN to actually look at it. You just want an image and you want to know what it is, and you want that image to go away relatively quickly. So having everything hosted inside S3, you can have a build lifeline on it, so you can actually destroy all those images after about say a few hours. So you don't overload your system or overload S3 buckets. You can just have it all immediately go away. So that's one of the reasons why we push the S3. We have latest versions of all the plugins and all the newest builds. All the dashboards are basically, all the dashboards are being dependent on Grafana variables. They're all being saved to our Bitbucket and using the WYSI CLI tool. And all the privy database usernames, all those passwords, all those things, those are all not inside of our Bitbucket implementation at all. We're actually using a secret service where none of that is inside of our source repo or inside the actual .ini files. So any of that privy information is actually blocked out. And the last one is the most important thing, is that we're actually able to move into our VictorOps alerting system. So basically, this is our Amazon ECS service. this is kind of like, a little bit of a view of my world of what I look into, but we have this cool feature where we can actually see all the individual tasks. We can actually see individual services. This is kind of like the groundwork that our team has built out. We can actually see a C Advisor, Graylog, and Kibana login sources. So if something ever dies, we can immediately look into those tests and see what's an issue with it. And I actually use that with our Grafana implementation right now. Moving into the Jenkins Pipeline, what we do. So I have a personal local development environment, but all the images are built using Jenkins and push up to the Amazon's task definitions and repositories. So when we launch the newest task definitions, if there's any problems, like we have a Docker build image just for each different part. So we have a dev, we have a test, we have a master for staging and production, and we have all the different pipelines. So if I want to build just the development one, I can just build that immediately, and then it immediately comes up, and it automatically gets pushed out to our Grafana.dev Chegg service. If I want to build out the test one, it takes in all the newest commits. If you commit something immediately, this will actually pick it up and actually build out the newest image immediately. You can immediately see how it's working inside the test environment or dev environment. And that's kind of like the idea of what we want to be doing as developers or as engineers in general. We want to automate all this work. We don't want to say, oh, I have to build this out and I have to test it out. It's like, no, it should be just done immediately. So a great example is that, if Torkin, who's the developer of Grafana, decides to push a new cool feature out, and it's like, oh, it's in the newest nightly build, I can just immediately test it out in dev, test, and push it out to production, and if it looks fine, I can keep it inside production with no problems. So we have automatic deployment. So one thing that we have available is we have a ability to roll back to any release if it's too much of an issue. And there's actually an internal Graphite metrics that Grafana uses. So this is a little bit of what happened in the last 24 hours. So like, yesterday, we actually had our service, the Grafana service actually die out. But since it's a Dockerized containerized instance, it actually was able to spin out a few new instances and actually was able to get through the problem. So even though that it died in the middle of the day, no one saw a blip of it because it immediately spun up and self-healed itself. So that's one of the benefits of moving from having Grafana being built out on an actual server, moving inside a Docker container makes it a lot easier. So going into mail serve, we have a mail service and we have images generated inside S3. And this is a little bit, I blocked out some of the pretty information, but important thing to have is that we actually have this as embedded as an image. So this is, right now that's pointed to an S3 image. And what we could do is that if people want to show that to other people, is that you can actually be able to, you can actually have the images passed on to other people, and it's really easy to just see it real quickly and pass it on. And this is kind of like a little bit of a window of all the different images that are saved from Grafana into S3. But one little quick note, since this is using Docker, sometimes you do not have all the different components that you need to actually make this work. I was tackling a big bug problem where none of the images or none of the snapshots were working with Grafana because I was building this all with a base CentOS machine, but it didn't have any fonts installed. And you would think that fonts would be installed on a CentOS machine when you start building it out, but because of that, it wasn't installed. It wasn't able to render any of the images or you being able to use the snapshot feature from Grafana at all. So it took me about a day or so and actually say, oh, it has no fonts, install fonts, boom, immediately working out. So if you do go inside the Docker world with your Grafana implementations, you have to remember some of those packages or things that you think are there are not going to be there. And then we could always go into the different plugins, and this is kind of like our little Docker file. So this is actually being built from our dev environment. So basically, we pull in the latest image. So this is the newest nightly build that the Grafana people make, and it always installs the latest plugins. So if there's an update to any of the plugins, it immediately builds out the plugins as well. One thing that I did want to go into is the LDAP logging system, and this is something that I had to go back and forth for quite some time. So the idea is that we want to have developers be developers. We want them to actually have access to everything, but they're going to have problems sometimes because they like to hang themselves. When you give them a lot of rope, sometimes they'll just take it and hang themselves. Or in our case at Chegg, we want to have our developers freely develop, but also give themselves the ability to shoot themselves in the foot. And that always happens here at Chegg on occasion, but that's just the development nature. Sometimes you're going to shoot yourself in the foot, and you're going to get through that problem because if you build around this idea, you can actually give developers free access to develop, but if you can self-recover from this, then you're actually able to move forward and actually develop a lot easier. So the idea with the LDAP login system is that I wanted to restrict people from making dashboard changes like crazy, but so I can lock things down. But if I want them to edit or add themselves an alerting, they have to be an editor or an admin to the system. So in that in mind, it's like, okay, should I have a different organization or should I have different dashboards? So things like that. That never really worked out. But what was really cool was that we actually have now dashboard source control. So using the tool that Utkarsh was able to make, we can actually take all those JSON files, update it to our Bitbucket repos, and if someone decides to change all the dashboards, all the financial planning reports that none of the technical people know how to access at all, we can immediately revert back by using that CLI tool. So big thank you to you for creating the CLI tool, because that made my decision as saying, okay, developers, you can actually make all the changes to any dashboard that you want now because we can self-recover. So now I give them the ability to shoot themselves in the foot and we can recover from it. And the last few things, we have a Siebert Service where we have all the usernames and passwords not accessible in our source control. But one thing that we could get around is that I was able to create all the credentials inside of a JSON file. And what was really cool is that I was able to basically implement this service that can actually pass in the credentials from a file and actually throw them inside all the different configs when we start the system. So this is actually kind of like a modified version of the official Grafana bootstrap file, which basically uses GoTo to actually launch the instance out by pulling in all the information in from all of our Siebert Service, throw it inside variables, and when it launches the server up, it immediately has all the passwords and everything it needs to inside its when it starts up. So moving forward, in terms of all of our different data sources that we have at Chegg, we have a Zabbix monitoring system for all of our old hosts. So this allows us to have a specific dashboard for any system that we want. Since it's templated, we can actually access and select any server inside of our system, be it inside production, test, development, or even some of the other preview areas as well. We have a bunch of different environments here at Chegg, so being able to access any server from any environment allows us to really move forward. But we also have a Grafana metrics service, so we decided to import all of our different Grafana metrics into its own dashboard. It's a lot easier to actually access this, and you can use different plugins because we have multiple teams, and if multiple people are looking at the same source, I built in just a little clock on the top just to say, hey, who's available online if we have a site outage. Well, you can coordinate and say, okay, it happened in my time at 11:30. Well, if I'm working with someone who's in Hawaii, then we know what time it is because we actually do have someone in Hawaii helping us out. But if we're also working with the Ukraine team, we can at least say, okay, it happened at this time. Did it happen at UTC time or did it happen during Ukraine time? You can easily figure that stuff out. And then finally, we also have the Amazon CloudWatch services as well. And this is custom name spaces that we have that we can actually have different metrics for any services that we have. So this is actually using the ETF services just to say, okay, what's happening to Grafana inside ECS and how much memory reserve it's doing fine because it's not doing anything for the last 30 minutes or so because I just did a release, but I was looking at the test one, so it's completely fine, so I can actually maybe scale that down and maybe not use as much CPU or memory. So that's kind of the cool little things about that. You can do a lot of different tweaking with this as well. So, and then they also have the ability to add new sources like Prometheus or InfluxDB. If we want to add any of those data sources in, we can throw that stuff right into Grafana easily, and we can build up those dashboards fairly easily. Now, the one last thing that I really wanted to get into was the alerting system. And right now with Chegg, we were using Grafana to kind of help us out with a little bit of triage, but what we were using was the Zabbix Grafana Service. And what was happening is that we sent out these alerts to our HIP chat, but we say, okay, we have a link to where the graph is, but it's not really like, useful or anything that great. It was helpful to have a little bit of alerting service, but it didn't really help us triage. So what we wanted to do was that we wanted to have VictorOps as an endpoint for any service from Grafana. So now we have the ability to have any user create their own dashboards, maybe even their organizations, but eventually we want to be having them, we want them to be able to alert and create their own alerts in the future. So one of the main things that we want to look into was like, okay, how do we embed those images? Since we're building out those Grafana images out, we can actually embed those inside of our VictorOps service. So this is kind of like the thing I've been working on for the last month or so. I actually have a GitHub issue that I'm working with, and the idea is that, okay, you have an alert, you have something that's broken, you immediately get the image inside your app, so you immediately have a timeline of the service itself and seeing, okay, what is the behavior of it for the last hour or two? You can immediately see that on your phone when you pull your, so you get an alert, you know exactly what's happening with the system. And you can easily tell from right then and there, is the service actually flapping or not, or is it a false positive, or is it an actual issue and a major problem where everything's falling flat and you need to get your laptop out and you need to tell everyone and you need to send out a side issue immediately. And then everyone comes online and everyone goes to the same source and you figure out the problem and you triage your problem immediately. So right now what we want to do is that we want to make on-call suck less. We all don't want to be on call because one of the worst offenders is getting paged for false positives. This wastes your time, it wastes other people's time, and we don't want to waste our time when we're off-site or not in the office and we get paid for an issue that's not really an issue. So the main thing that I want to take away with using Grafana and using our different alerting services is that how do we make on-call suck less, and also to give people the ability to create their own dashboard, create their own alerting system, and create a visualization so they can immediately get the information that they want when an alert actually happens. And so that was my big takeaway of what do I want to have Grafana come to, when we have Grafana being used here at Chegg. I wanted to completely replace our monitoring system, and so people can just say, I want to get alerted for this issue and this problem. I know how to subscribe myself to that problem because I can alert myself for it. I can create my own dashboard, I can save it, and I can store it away, and if it goes away, I can completely revert it, and if someone else decides to fiddle with it, but they can still create their own stuff so people can expand on this and create a much better environment for everyone else. So that's basically it. I can show you guys our implementation real quick. Let's see. So I'm just going to show you, this is our Grafana service internal metrics that we have, and we also have different things as well. I'll show you the Grafana health, but we have different ways to see, what's happening with the system immediately, and we can just see, okay, how much metrics are coming in? Is there a problem with the actual service? We always have Grafana go belly upwards, so I created this dashboard of saying, okay, what metrics are flowing into here, if it's actually being used on the carbon cache, if it's actually being used on the relay, or what is the main issues and problems. So by having this available, I was actually able to truncate out a lot of unnecessary metrics in our system, and I saw that things were getting relayed that caused a huge strain in the system, and a lot of it was looking on this outdated sources that we had that no one was using. So I talked to the few people that are owners of it. They say they don't use it, and I was able to chop them off and restart the services and immediately solve the problem of okay, I don't need as many metrics as I need to. So this is one of the nice things about having a service like Grafana is that you have a great visualization on any service that you need to actually work with. So if you have any questions, feel free to answer anything right now, but that's my presentation.
I have one question about hosting the image on S3. So that, and you want to say you don't want to connect to VPN on your phone and then just access it. Then we just open there.
It is, but at the same time, what you can do is that you can just have it have that image sent out inside VictorOps, and so you don't actually want. Yes, if you have the actual URL to S3, yes, you could do that. But then, what do you want to put inside there, and what images are inside there? Like all those images that you saw before, they're all different scrambled hexadecimal files, and then after about an hour or so, they immediately get deleted. So you can't actually do that. So if people somehow do get your S3 endpoint, it's like, okay, at least those images they won't stay there forever, and you can immediately just say they get deleted.
What's VictorOps?
VictorOps is like a PagerDuty, so it's like an alerting system. So what we have here is at Chegg is that we have all of our different development teams have a VictorOps account, and if there's any problems or issues, in PagerDuty, it sends out alerts to those teams, and it automatically pages the people that are in rotation. And if there's any problems or issues, what you can do is that, and one of the main appeals of VictorOps is that you can actually have a centralized talking center where you can actually have everyone who's on call, who's my on-call person from, the front-end team, who's my on-call on the database team, who's my operations on-call person. If you go to the main VictorOps portal, you can actually see who's on call on the left-hand side. You can see what issues are open, and then a centralized talking area in the center.
Is it complementary to PagerDuty or
Yeah, it's a replacement. It's a much more robust version. One of the best things that we actually use VictorOps here is that we also have HipChat here for our company. But what we do is we have the main dialogue of everything that's coming inside VictorOps connected to our mission control inside HipChat, which allows not only people that are on call in VictorOps, they can actually talk to people inside of HipChat as well, so that everyone is all on the same page. So instead of having different chat platforms, you have one centralized platform that's synced up and integrated together. And you can see which alerts are coming in, who's getting paged, if they didn't acknowledge it or not, or which services are really acting up.
Does Grafana support the integration to the VictorOps, or you guys have written your own integration to the VictorOps?
I'm sorry, what was that?
Means who sent out the notification to VictorOps, like alert?
So that's actually one of the newest features that Grafana 4.1 is available. So the beta is out, and that actually allows to have VictorOps integration as well. So if I actually go here, we actually have our alerted services notifications. We actually have a VictorOps type, and we actually just have a URL that sends out all the different. So this is actually sending out to our VictorOps inside. I believe our operations team, so only the people from operations get these alerts. But if you wanted to have other teams available, you can actually say, okay, I want to create another new VictorOps type, but I can send it to another team.
Question about alerts mechanism in Grafana in general. So what I hear from one of our engineers is in cluster environment, when you have multiple Grafana instances, you can configure one alert. It's either all of them start sending the same alert, or you assign one node that is become the alerting and becomes a single point of failure. Is it correct or?
So right now, Grafana does not support multi-node instances, but one cool thing about VictorOps is that it can handle multiple alerts from the same system and only sends out one alert. So we've never had that problem. So in terms of Grafana is never supported multi-node, well, one of the nice things about VictorOps is that we don't ever have to worry about that problem. We only get, it send out, what if we have a, multi-service, 20 services of Grafana, and it sends out 20 alerts. VictorOps will take that in and just send out one alert to the team.
Can we go back to the previous screen?
Yeah, sure. Let's see. There we go. So we have also different, we have a lot of different dashboards that I've created here, but some of them, let's do the,
No, actually.
no, we have a shared dashboard. So this is a fun dashboard just because of the fact that this is important information, but they decided to label everything as burrito consumption, birds of prey, bathroom usage, and chickens. But these are actually just trends of different data. It's actually, those are real statistics, but these are actually real statistics, but they just change the names of everything, so you don't know what it's actually doing. And they also have a blow nose annotation, and what that really is, this is actually one of my favorite things. Oh, it's my phone. It's telling me I need to do something. There we go. So anyways, we have this annotation called blow nose, and what this really is a deployment mechanism that they have with their graphite and Nagios system. So this annotation right now, it's actually dark blue, so you really can't see it right now, but there's one here and here, two up here, and what happens is that this is just an annotation when they actually rolled out a brand new push. So this is just an annotation to say, hey, did we push any code recently? These annotations show release. And so if you see everything start dropping, and all your services start dropping, and you see that that release was just thrown out, then you know that the release is responsible for the drop of your metrics.
I have a question about the conflict of alerts. Conflict of alerts. Again, maybe if we look at these charts on the left, they are cyclical in nature, right? So just going to zero doesn't necessarily mean something goes wrong, unless it's somewhere in the middle of this thing.
Yeah. So this is one of our teams that had this already, and so at the start of the day, so what these metrics were saying is just what's the trend for the entire total for the entire day.
My question was, again, how do you set the upper and lower thresholds in this case? They don't make sense, at least if you just set a static threshold. Right? So static thresholds don't make sense. Are there any ways to set up dynamic thresholds based on maybe time on the data?
So we got.
There's nothing right
time on the day, maybe again a rolling window, or maybe it's again based on a pattern, maybe based on machine learning patterns.
So there are a few different things, and unfortunately, one of the dashboards that I've worked on right now is one that we have for our orders, and that's not really to be seen by public eye quite yet. But what I was able to actually develop was a derivative function of our orders. And what this has is that, okay, do we see any sudden spikes or sudden decreases with our orders? And what we can do is that we can set up an alert to say if we see a derivative of -500 or -1,000 within a 15-minute period, we know that orders suddenly just dropped like crazy, and we can alert on the actual derivative of that. So there are ways where you can actually say you want to set up some complex math functions. We can actually have different metrics, so you have a completely different query available, and then you can have that as a derivative or an integral of what you need to have, and have it alert on that fashion. And so what you can do is you can actually set up different accesses. You can have one on the left and one on the right. You can just have the alerting system on the math functions on the right-hand side, as opposed to having all your different all the different metrics that you have. You can actually have all your math statistics and anything that you need to do specifically to be built out.
I just want to add on this one. We use the boson alerting services, and which actually allows all those things. The boson alerting service works over the time series service. There's nothing with the graphing. So in that you can define the expression saying, if my trend is like deviated by a couple of percentages from the last week or from the last day, then so because that way you don't have to define the static one. You would be knowing it, like if some new release has gone this week and if your standard pattern is deviated by a couple of percentages from the last week, then notify me. And we use a lot of all these expressions in our case, because when we get some network or internet issue from the customers who get disconnected, we don't know like what's the exact number when the number of online customers will be like any fixed value. We go to the last 8 weeks and take the mean of that every movement. And whenever the trend gets changed as per that, we know that some network issue or some internet issue is going on.
What is that? Is it again?
The boson alerting service.
So you deploy on the data source server itself?
So we have the OpenTSP, any of that one with the OpenTSP, we can deploy as a separate boson alerting service.
No, but actually you're giving direct access to the data source itself.
Yes, that source access to the alert.
B-O-E-O.
BOSUI.
It's like a alerting service on top of time series data.
This facility is also on OpenTSP. I think they are working with InfluxDB also.
And Graphite also.
And Graphite also.
You can have it sitting on top of any of these data sources, and that can alert you and help you write complex expressions which you want to write.
Is it pluggable?
With Grafana? Yes. So there is a boson data source. I think Kyle is the guy who has written boson. He has, I think there should be some GitHub repo which should point to the boson data source. So you can actually write all those complex expressions in Grafana itself.
All right. Any other questions, guys?
Yes, I do have one question.
Sure.
Hopefully one.
It's all good.
Do you have a way to manage teams in Grafana?
See, that was the biggest that right there. Yes, there are ways to manage it, but right now the people at Grafana haven't really built out so much support with it. So what you can do is you can actually create different organizations, and then you can have different organizations for your different teams. But one of the main issue with using organizations is that it's not very clear which organization you're in when you're, like, say you have like 3 or 4 different teams, and you have one team that has all their dashboards, and they want to share that with other people from the other team. They're part of a different organization. They don't see those dashboards unless they actually log in, change their organization to the other organization. Even if they do have access to it, it doesn't really recognize that they have access. So the whole organization to have different teams is almost there, but it's not quite clear or intuitive enough where an active user wants to actually have have a different organization as opposed to everyone else. So eventually I believe that they will fix this, but right now the organization and team approach doesn't really work out too much.
It's not really good because per organization you have data sources. So if you go to another organization, you will have data sources and dashboards for that organization. But between teams, you want to keep the same sources and
one person can do multiple teams.
Yes.
Right? And in some organizations, in some companies, there are hundreds of teams. So
Exactly.
it can be too overwhelming.
Exactly, and I completely understand, and I hope that eventually the organizations it only needs a little bit more tweaking.
Yeah.
It just needs a little bit more intuitiveness of saying, okay, which organization am I in, and if it automatically understands, like, this user is part of this organization, it doesn't say you need to change your organization. If they actually implement different ways to do that, then I think it could be a whole lot better. Just needs a little bit of tweaking. But again, it's open source, so if there's a way to fix it. I'm sure the people at Grafana, if there's a way to actually create a much better and more intuitive organizational system, so teams can actually have it, you can actually make those changes as well.
So what kind of, differentiation you want to have between teams? Like, you want to have separate dashboards, separate, like, why do you want different teams to have different kind of access? Do you want to have different kind of access?
I think within the company, read access is fine. Right? So it can be open to everyone unless some executive dashboards can be hidden. But the the right dashboards, again, they should be available within a team to edit, and some people leave sometimes, and other people in the team should be continue to edit. But from other teams, we don't want to come to our team and to mess with our dashboard.
Yeah, so think of it as, so we're in a big company, so we've got many DBAs, many front-end teams. So you might have a single DBA, you might have a two front-end team. So they should be part of that team, right? Be able to see their charts and do all that information, but they're still a DBA, right? And they're still part of the DBA team group. So that's what we're kind of going through right now in terms of you have a single user who exists in a hierarchy, but within organic teams too, and how to allow them to have access.
So it's almost there. So there are LDAP configurations where you can actually have different teams to be part of different organizations and actually give, like, this LDAP group only read-only permissions, or give another team admin permissions of a different organization. It is possible to do that. It's just, and it is a function where you can actually have organizations be the solution for that. The only issue is that right now, if you want to share those dashboards between different teams, right now the organizations to move things back and forth is not really, like, you'll get some hang-ups and some headaches from it, but you are able to use it in that fashion.
I think the current solution could be just like not using organizations at all, and because then it's kind of like a complete segregation of dashboards and everything, and then you have to redo stuff as administrators. So just use LDAP if you consider using it, and use that for permission level, and then you can always take like backups of your dashboards into GitHub. You can version control them anyway.
Yeah, the problem is like we have like hundreds of users, which will become thousands of users. That then becomes like messy, right? And you're like, okay, how do we make this functional for people?
So everything can have their own GitHub repo for their dashboards, right? And not, you don't have to do it for everyone. And then they can just take their dashboards back up from their orgs or whatever their data sources back up, and then have them version controls themselves as a part of code.
So I can just show you a little bit of the hang-ups right now. So right now, let's say I'm logged into the server right now. I'm inside the shared organization right now. So I have a link that I have, and I want to say, okay, I want to open up a link, and I don't actually want to see this. It will pull up easily and just comes up just fine. But as soon as I say, okay, I want to switch my organization to a different organization, all of a sudden, I have nothing in here. I have no data sources whatsoever. I have no dashboards. And if I actually do want to see that thing I just had access to, it says I can't find that dashboard. So right now that's the main problem, and it's not really telling me which organization I'm part of. Unless I actually go to here, it kind of tells me I'm part of the temp organization, but not really. It's not intuitive enough where an actual user will say, okay, I want to actually access these other data sources, but I have to change the organization or share it to other people. So the people who aren't actually inside the Grafana world don't really know how it is. It just needs a little bit of tweaking to say, okay, are you part of a different organization? Or if you are part of a different organization, you logged in somewhere else, you can still see that same dashboard. If they took care of that problem, then I think it will be able to serve your needs of what you're looking for. That could be a good, say, hey, if you want to create a GitHub issue and say, hey, if we can have a little bit more intuitiveness where organizations, different dashboards can share off, I think that could actually solve your what you're looking for. Any other questions? All Alrighty, well, thank you all for coming, I appreciate it.